All right, good afternoon, or shall I say good evening. Hope you're not too hungry yet. I feel happy to be here because I've been able to develop some software. I was trying my demos in this afternoon, and apparently SignalR just released a new version, and I had to redo all my demos. I'm also an IT pro because I actually connected my network cable, so yeah. And I'm also an AV guy. I actually did the transition myself, so thank you guys. SignalR. SignalR coconut toothpaste. I thought, why not be funny and talk about SignalR? You all know this one. You all know Scott Guthrie actually brushes his teeth with SignalR in the morning. Yeah, I think so. Okay, good. Actually, I received a slide deck we could use for TechDays from Katrine from Microsoft. And she sent me this nice Metro deck, and I was like, oh, wow. I get to do tiles, I get to do animation and stuff like that. Actually, this one took me, I think, 10 minutes, after which I got bored and actually just copied some other slides in. But this will be the one and only Metro slide you will see, the real Metro slide. My name is Maarten Baljouw. I work for Real Dolmen. I see all my colleagues are in front of the audience, so thank you for making me even more nervous. I'm from Antwerp, as you can see in the nice Metro-style Antwerp icon. As you can see, we're always in front of everyone else because we have a Metro-style logo. I'm an MVP in Windows Azure, used to be ASP.NET, and I'm also still working on ASP.NET. It's a great technology to work in, but I'm working in both web and cloud at this moment. If you're interested in cloud, I'm also one of the co-founders of the AZUG, so if you're interested in that one, feel free to join us for a meeting. I think we have pretty soon an introduction to Windows Azure session where you actually can have hands-on, so a small commercial plug at the beginning of this talk. The agenda for today. Whoa, I should have taken black slides because the light is very bright at this moment. Actually, SignalR is a technology that you can use to have real-time communication between the server and the client. So I'm going to briefly cover what real-time is, why you would want real-time in your applications, and how you can do that today, and all the variants that are available. After that, I'll cover SignalR, and I'll give you an example of how you can use SignalR to actually use all these fallback methods to fancy HTML5 WebSockets and stuff like that. I'll cover connections and hubs to core principles in SignalR that you can use in your application. I'll do some demos, some pretty impressive, as I might say, and some Q&A at the end. And I was told that we should leave in 1 hour from now, because otherwise they have to pay extra, or we can see a movie. Okay, so why real time and how? Actually, this morning, for once, I didn't have a traffic jam, and I arrived here pretty early. And there were some colleagues of mine also in the partner area, and there was no coffee. So what we had was one of my colleagues walking over to the coffee stand every time and asking, "Do you have coffee already? Do you have coffee already?" That's not real time. He had to walk there, and we wanted real-time info on when the coffee would be ready. So that's why you want real time. And actually, we're pretty used to real time. If you're on Twitter, you'll get the latest tweets in almost real time. It will take a minute or a few seconds, but you'll get the latest tweets real time. If you use Facebook and you chat with each other, you have real time. You have real-time communication in your browser. Eventually in your browser and using MSN Messenger, but you have real-time communication between those. Wouldn't it be nice if you put something on eBay, for example, and you want to make sure you have the item that you want to have for a certain amount? Well, just have real-time information about the actual ongoing bids on eBay. You want the real-time information and be able to quickly go one euro cent higher than the last bid and make sure you own that item. Live scores. If you're watching a soccer game, maybe you want live scores and live reporting of the match, and even on places where you can actually watch the match or listen to the radio, you want real-time info, maybe in text format. You want real-time notification. If new mails arrive, you want a toast message saying, "Hey, you have new mail." Lots of different scenarios, that you already use today and that you are used to doing. But in fact, it's not so easy to do all this because there's lots of different technologies, and that's something SignalR is trying to solve. HTTP, since we're talking browser, HTTP is actually quite old. It's an old beast. It was never intended for real-time communication. If you think of HTTP, it's really request response. Your client makes a request to the server sends a response back to the client. It's not intended to have bidirectional communication all the time. It's also always the user who has to trigger a communication and get data back from the server. It's always like that. Anything you do on the web is like that. So the web is stateless. Request, response, and no in between. If you want to have state, you have to find something to do that. If you want to communicate from the server to the client, you actually have to abuse the request-response scenario in some way, right? HTML5 WebSockets, why not? It's a solution. Everyone is yelling HTML5 WebSockets can solve this. We can make the web real-time. We can do this with HTML5 sockets, right? How many sessions have you seen on HTML5 this week? Too many? That's an honest answer. I think you've seen WebSockets in there, but there's some, well, drawbacks to WebSockets. I'll start positive. It's an extension to HTTP where you have the request-response cycle, and you can actually have communication from the server to the client over WebSockets. It provides you raw sockets over HTTP. Everyone knows what a raw socket is? It means you own all the data that's going across the wire, and you have to decide how you will do the transport over the wire. It's just bits and bytes going over the wire, and you have to decide about how your protocol will look like. It's not that you get XML format, or not that you get a JSON format, or SOAP messages or stuff like that. It's just a raw socket, just like you connect to a telnet server or whatever that you're doing. An advantage is it's full duplex, so you can have communication triggered from the server and get it to the client. So the server can actually send messages to the client. Another fun thing is it traverses proxies. If you want to, for example, remote desktop from your PC in your company to an external server somewhere, you will probably not be able to do that because there's a proxy server prohibiting you from accessing the outside internet and stuff like that. Well, WebSockets actually allow you to have a line of communication between your client and your external server just using raw sockets. Now there's some disadvantages as well. It's still a draft. I think Chrome almost every 5 minutes has a different version of HTML5 WebSockets. I think Firefox is in the same boat. It's still a draft. There's a lot of changes. No one actually has the real spec implemented because there is no real spec yet. So it's difficult. You're never sure if it will be stable, if it will work, if it will keep working, if you log on to your PC tomorrow. So that's a disadvantage. Another disadvantage is not every proxy server supports it. Typically in enterprise you have proxy servers and not every version of proxy servers does support it. Not every web server supports it. If you want to try WebSockets on IIS 7 or IIS 7.5, it won't work. You have to have Windows Server 8 or Windows 8 with IIS on it to have WebSocket support on Windows. There's some other platforms that support WebSockets, but on Windows you're actually tied to having Windows Server 8, and as we all know, Windows Server 8 is not even in beta, so difficult. Not every browser supports it. There are some browsers of some vendors that don't support it. There are other vendors that actually support it, but every 5 minutes change the version, so that's not optimal as well, and you probably don't want to have that in your software. And then another disadvantage is, it's an advantage and a disadvantage, those are raw sockets. If you want to create a web service, you create a proxy to it and you have a protocol to communicate between the client and the server. But the problem is with WebSockets and raw sockets, you actually have to invent a protocol yourself. You can use SOAP or something similar, but you have to develop it yourself, which means you're actually building a communication stack that the platform maybe should provide to you. So it's difficult. Now, since we've always been using real-time-ish communication in the browser, there are some techniques that have been developed to actually have something similar to real-time communication, where the server can send data to the client. One of those is the forever frame technique, which is a technique that uses HTTP chunking, which means my client initially connects to the server, and as you can see, the server will return a transfer encoding header and say chunked. And every time a \0 sign is sent over the wire, the browser will actually retrieve the data and will be able to do something about it. So typically in a forever frame communication, you see something like this, where the client initially connects to the server keeps the connection open, says it will be chunked, and that the connection should be open until the connection is closed by the server. And it will just send data to the client. This is real push. It's actually the server sending data to the client. The problem is it's a connection that stays open. Your server has to maintain that connection. There's server threads involved. There's proxy servers. If something goes down, you have to reestablish the connection and stuff like that. It's not optimal, but it works. Another technique is periodic polling. Maybe you've been using that as well. You have some AJAX call going on, and you wait until a result comes in, and then you poll again, or every few seconds you communicate with the server, and you ask, do you have new data for me? And the server sends it back. So something like this will happen. Every few seconds a request is made to the server, and the server will give you a response immediately if there's data. It will not give you a response if there's no data, for example, but it's really on a certain interval that you do the communication with the server. Now the problem with that is that you have some polling interval. For example, every 5 seconds, which means if I connect to the server and he has no data, and I disconnect, and suddenly the server has data, I have to wait at least 5 seconds before I will receive that data, because my polling interval is every 5 seconds. So I actually have a delay on my real-time communication. If I'm a stock trader, for example, and I'm building a stock trading app using this technique, I'm sure some people will not be happy doing this, because the value is not real-time enough to do that kind of business. There's a polling interval. You can poll every few milliseconds as well, and that will work. But the problem is you're using a lot of resources, both on the client, who has to open a new connection every few seconds or every few milliseconds, but also on the server, who has to handle the request, who has to fire up the ASP.NET and the IIS processing pipeline, so you'll have trouble managing resources, and you will soon grow out of server capacity. So you have to find a balance between the polling interval and how real-time your application should be. So it works, but there are some disadvantages. I'm going to give you a quick demo. If you open Fiddler, for example, and I open my Twitter client, you will see that, actually you won't see it, because Hootsuite, this Twitter client, going to start zoom it as well. It is downloading a lot of images. I will just get rid of all of these. You will see that it's not giving me any data here, but Hootsuite, what they are doing is periodic polling almost every minute. So after a minute, you will see some data going across the wire where my browser actually asks the server, do you have new data for me? What are the new tweets that I should display? It will return the data. Is this one? Nope. It will return the data. My client will render it, and after another minute, it will reconnect to the server, ask again, do you have new messages for me? And eventually display those in my browser. It seems we're not getting any information out of this, so no problem. I promise the next one will give something. There's another technique that you can use, long polling, which is actually something you can do using AJAX. You can connect using jQuery to a server, both in periodic polling, every few seconds, every few minutes. But what you can also do is do long polling. Connect to the server, and the server can keep the connection open until it has data, and then return the data, immediately reconnect, and then again wait until there's data, send the data back, wait until there's data, send the data back, reconnect, and just like that, you can go on, and there will be no delay, and you will always have a possibility where the server can send data back to the client. Now, the problem with this one is you have to make sure your connection stays open. And you have to manage something if the connection breaks or something happens during that long polling where the server is actually just waiting for data to send to you. If that happens, you will have to have both client-side code and server-side code, which handles this situation and which will be difficult. I'm going to quickly show you more visually how this works. If you go to Facebook, for example, and that's where I need the help of some colleagues. If I open my Facebook, it takes a while. Okay, I'm going to delete this one again. Someone send me a chat message. Or something else. Okay, there we go. You see, we have a long-running connection here. We don't get a status. It's still open. I'm actually connected to Facebook. My client is requesting data on Facebook, but Facebook is not sending me anything. Until someone of my colleagues send me a message, the server has data and it will immediately send me the message as well. And then reopen the connection and just wait until there's new data. So if you look at this, there we go. We have a message now. The message is in there. It was Tom Janssens, apparently, who sent me the message. And I receive the data from the server. I immediately reconnect, and this story will go on and on until I log out of Facebook, which I'm going to do because I see a lot of people trying to spam me. Okay, there we go. So you see, you have the periodic polling where you just check on an interval, and you have the long polling where you connect and just wait until there's data that the server can send to your client. Now, unfortunately, it's a bit like this. The light is less bright, so thank you for these slides. It's a bit like this. You have too many options. If you have to develop something which supports all these kinds of methods, and actually there's more. You have forever frame, you have periodic polling, long polling. There's HTML5 WebSockets, and also Opera. They have a server-side, server-sent event technique, which they use to, well, it's a predecessor to HTML5 WebSockets, actually. So that's 5 options you have. You don't want to develop these 5 options in your code, right? You want to make sure if a client supports WebSockets and the server supports it, that the transport will be WebSockets. You want to make sure that if the client doesn't support WebSockets, you can fall back to long polling or periodic polling or something. The same thing you do with jQuery, for example. If you write codes to modify your document object model in HTML, you typically do that using jQuery. Actually, you don't even have to think anymore about the browser differences because you know jQuery will take care of that for you. And that's what SignalR will do. SignalR will make sure the client and the server both talk the same language, and you don't have to care about the transport. SignalR will take care of the transport. It will give you a new protocol that you can use to communicate between the client and the server and the client. And it will make sure, well, whatever transport is used that is optimal in that situation. So meet SignalR. Just to make sure you know how to pronounce it, it's SignalR, like the pirates. So SignalR. If you want to practice, go ahead, no problem. So SignalR, it's 3-in-1, just like toothpaste sometimes is also 3-in-1, SignalR is actually also 3-in-1. It's a persistent connection, and why persistent? Because if there's WebSocket support, SignalR will support WebSockets, and we'll make sure there's an actual persistent connection between the client and the server and the client. It's persistent from the moment you go to long polling or periodic polling, but you won't know. You will develop against the connection, and SignalR will take care of all the errors that can occur, of all the long polling and the falling back from WebSockets to polling and stuff like that. It just abstracts the transport, and it will make you focus on your code, focus on your communication, the real-time stuff that you're trying to build, and it will just make sure there's a communication between the client and the server, whether it's WebSockets, whether it's long polling, or whether it's something else. It's also very interesting. If you have 5 clients and one supports WebSockets and the other one supports long polling, for example, SignalR will make sure every client gets the preferred type of transport, but you won't notice in your code. also fun about SignalR is it's been built by David Fowler and Damien Edwards. People who have worked with NuGet will also recognize these names. They've been pretty active on building SignalR as an open source project. It's not a Microsoft project, not Microsoft funded, I believe. They have it on GitHub, so you can fork it, you can write contributions to it. But I suspect it will ship or in some form, or it will be featured in the ASP.NET stack. So that's why I added the yet after the it's not a Microsoft project. It's simple to set up. Just install the package through NuGet, and you're ready to go. Also, something that I really, really like, I hope I don't offend too many people in the audience, it's C# only. No VB.NET. So C# only, .NET 4 or 4.5, and jQuery. So there is a dependency on jQuery as well. You have to use jQuery on the JavaScript side. So where do you get it? Well, there. Install package SignalR. Where else? Through NuGet. And speaking about NuGet, a small commercial plug. Me and my colleague Xavier have been writing a book, which took us a while. Go to this link, make us happy or make our wives happy, so we can at least give something back from the royalties. So let's give a quick demo how you can use SignalR. What I'm going to do is I'm going to open a blank project, add a small demo to it, and give you a quick overview of what you can do with SignalR. Just a real fancy, nice thing. And then we'll break it down and start easy and go forwards using that. So what I'm going to do is I'm going to create a new project, a simple empty ASP.NET web application. So nothing in my sleeves, nothing in my project, all empty. And in there, I'm going to install SignalR through NuGet. And you will see, I'll do it on the command line. If the PowerShell host, yep. So I'm going to install package SignalR. And the SignalR package is actually a meta package. It's a package that just references two other packages, the SignalR.server package and the SignalR.js package. Why is that? Typically, maybe you want to build your client-side code in a different project than the server-side code. So then you can select the individual packages. Now, if you want to have SignalR just hosted in one project, just install this one, and it will grab both of the other projects as well. So what you will see from this is that there are a few dependencies. My SignalR package installed the SignalR.js. It installed the SignalR server and the SignalR hosting.asp.net packages. And you also see a dependency on jQuery and the Newtonsoft JSON. So it grabs a few packages to have your code running in there. Now what I'm also going to do is install another package, which is the SignalR.sample. I love doing demos like this because you just download them and they will work. So I hope my next demos will also work because I'm going to live code them. I was talking to you about a stock ticker. And that's actually one of the samples that comes with SignalR. You can install a sample package, which features a nice little stock ticker with 3 stock, Google, Microsoft, and Apple. And I hope, because the last time I ran this sample, Google was winning, so I hope Microsoft will win this time. We'll see about that. Going to open Firefox as well. And why not? Let's open Chrome as well. And go to the same pages. There we go. And I'm going to open the stock market. And I want to see live real-time results of what's happening. So you see across all browsers, all the updates are coming in. There's one server side doing all this logic, simulating a stock market, but sending all the updates to all the browsers. And I think my Chrome may be using WebSockets. I don't know. And actually, I don't even care. Firefox will probably use long polling. IE will do the same. But it just works. I have a stock ticker working. I have a virtual stock market sending real-time updates to my clients. I think it's nice. Yeah, Microsoft is losing. Oh. It's Google winning again. I don't know. At least Apple is down. So, I'm going to close the stock ticker, and now I'm going to really live code from zero, actually an example of how you can use SignalR. Everybody get your Twitter clients ready? Okay, so what I'm going to do is in my web application, I'm going to do one of the better best practices available. I'm going to add a global ASX, which is fine. And I'll use that file to write all my code, so all classes will go in there. Don't try this at home, or your company, or wherever. What I'm going to do is I want to create a quick new style Hello World application, so it has to do something with Twitter. I'm going to just display all the latest tweets featuring the TechDays BE hashtag. So just wait a second, and then you can tweet, and we'll see them coming in live. So what I'm going to need for that is a new class, which will be my tweets connection. I'm going to make this a little larger. So I'll have a tweets connection, which will inherit the persistent connection, which is a base class SignalR actually features. So I'm going to add that one. Oh, too much. Going to add a couple of other namespaces as well, just to make sure I have them all at once. I'm going to include the ASP.NET hosting namespace, and I'm going to include the ASP.NET routing namespace. Because if I have a tweets connection, actually my client should be able to call into my application. And what he's going to do? Well, he's going to just connect to one endpoint, which I have to define in my routing table in ASP.NET. So my tweets connection actually will be nothing more than this one. A connection has some virtual methods where you can, for example, when someone connects, act on that. When someone disconnects, you can act on that. When data is sent, when data is received, you can act on that prior to the event and post the event. But I'm not going to be needing any of those, so I'll just have my tweets connection inheriting the persistent connection. Next thing I need is a route. I have to register this connection in an endpoint, so what I'm going to do is in my route table, I'm going to my routes, and I'm going to map a connection, which is the tweets connection, to a URL called tweets, and the route will look like tweets slash who does not know what this means? Anyone? This is just ASP.NET routing, in fact. And what I'm telling SignalR and ASP.NET in this case is that I want to have a tweets connection handling new connections. I'm going to give it a name, tweets, and I'm going to expose it on the URL blah 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 slash tweets slash something. And that something will be an event, a send, a receive, something like that. And that's why I call it into an operation variable in which I'll catch all information that's coming into the URL. So that ends the asterisk. Okay, now I have to do something. You really don't want to try this at home. I'm going to create a thread just running in my application which will send out new tweets every few seconds. So what I'm going to do is in my thread pool, I'm going to queue a user work item, which will do nothing. There we go. So what I'm going to do is create an infinite loop, just getting new tweets and sending these tweets over my connection. So what I want to have is my connection manager. My connection manager is a class responsible for mapping incoming connections, actually. So I'm going to get this one from my SignalR.hosting.ASP.NET. Where is it? .ASP.NET host .dependency resolver .resolve. No, resolve. You see, it's a lot of code, but actually you don't want to do it like this in your actual code. You want to have a separate class responsible for managing this connection. But I just want to show you in the most simple form how you would do this. So I'm going to resolve the tweets, not the tweets connection, the iConnection manager. There we go. From that connection manager, I'm going to retrieve my connection. So I'm actually asking the environment, give me a connection to this tweets connection so I can send data across the wire. So I'm going to ask my connection manager, give me the connection named tweets connection. From this moment on, I can ask my connection to broadcast. I can send data to all my connected clients, whether they're connected through HTML5 WebSockets, whether they're connected using Forever Frame, periodic polling, doesn't matter. I'm just going to broadcast across all these clients, and I don't care what the transport is. I can broadcast to all, and I can send to one. Send is if you have an incoming connection, you can send data back to one client. Broadcast is just send it to all. So the stock ticker example actually sent the data to all the connected clients. So what I'm going to do is create a nice little loop. I'm going to add a thread.sleep on the end, just to make sure I don't encounter the Twitter API limits. There we go. And I'm going to pull in another package through NuGet, which will be linked to Twitter, which is a nice open source wrapper for the Twitter API that I just have an object model to retrieve the tweets from Twitter. So in here, I'm going to write a using tweet. No, that's not the one. Tweet context. Ah, come on. Link to Twitter.tweet context. Twitter context is a new Twitter context. And I'm going to use that one to search for the TechDays BE hashtag. So I want to have a list of tweets equals my context dot search dot where my search dot search type type is in fact a search. And my query will be something like TechDays BE. I want to get the first one of that, well, a single result, and I want the results of that, which is the list coming out of the link to Twitter API that I want to just broadcast to my clients. I'm not going to do any conversions to JSON or to XML. I'm just going to send this across the wire. So on my connection, I'm going to just broadcast all the tweets. If I run this, nothing will happen. I just have an infinite loop every second checking Twitter for new tweets. Awesome. Let's add some client-side code as well. I'm going to add a new HTML file. Just so you see, you don't actually have to use ASP.NET or ASP.NET MVC or whatever client technology that you're using. You just can write your code in HTML. It's just JavaScript. So, tweets.htm. What I need is a few JavaScript files, and those are jQuery, because there's a dependency on jQuery. SignalR requires jQuery to run. And I'm going to add SignalR as well. So SignalR is a nice client-side library that you can use. In here, I'm going to quickly add a title and a list which will feature all the tweets that I'm receiving from my connection. One thing I have to do is the actual glue between the client and the server. So what I'm going to do is add some other scripts. Whenever my page is loaded, I'm going to execute this function. Okay, I want to have my connection. My connection, I can actually receive that from my $.connection. So actually, what SignalR did was extend jQuery and add this connection variable, which I can use to interact with everything SignalR has to offer. So from my connection, I am going to retrieve my tweets. So remember, in the routing, we had, where is it? We had this little guy. We had a named connection, and we named the connection tweets. That's actually what we're referring to from the client in this case. I want to get that connection, and I want to start my connection. So I have to really explicitly open my connection, whether it's HTML5 WebSockets. I have to establish some sort of information exchange with the server. What I can do then is add one extra method. On connection, whenever I received data, I can execute this function. I will have a callback whenever I receive data. And what I'm going to do is search my tweets list. I'm just going to clear it, the most ugly way how you can do this, but anyway. And after that, I'm going to append for each element in my data. I want to execute a function where I have an index and an item. I want to execute that one. And what I want to do is just add one list item to this tweets list. So I'm going to add, yet again, ugly jQuery code. I'm going to quickly just add the data.text. Why data.text? Because the class I actually returned from my C# code was just a searched tweet or something from the link to Twitter client library. And I just returned the list of all the tweets. So what it will do is serialize for me all this data into JSON, bring it into JavaScript, and I can just consume it here just the same way I would consume it from .NET or whatever language. So I'm going to run this, and I have a lot of undefineds. I must have missed a property. Just going to quickly check. Item.text. Thank you. That's why. So refresh this, and we have a Twitter wall. Feel free to tweet, feel free to make a commercial, whatever. It will not really look real time for two reasons. One, I added a thread sleep for 1 second. And two, Twitter doesn't index all tweets immediately. So it may take a while for your tweet to show up. There we go, dental healthcare. Thank you. So we have some tweets coming in. Thank you. I've also noticed there was a lot of interest in Knockout.js, so I quickly crafted a demo using Knockout.js and SignalR as well. So you don't have to always use it together with Upshot or whatever. Actually, I had the same code here, where I just had the tweet connection and stuff like that. And I quickly created a view model using Knockout. So what I have is a view model on which I have a tweets property, which is an observable array. I have my connection on there, and whenever I receive a connection, I'm just going to push this new tweet into the collection I have on my view model. And this is my HTML. I just have a list on which I do a for each for every tweet, and then binds to the text property of every item. So let's run this one, and this one should also show all your tweets coming in. So there we go. Yep. Works with Knockout.js as well. Why the Russian? Or the Greek? No, it's UTF-8, I think. Okay, so what just happened? My server was actually sending data to the client. It was not my client doing an explicit call into my server asking for data. It was really the server sending out data to my clients. My clients are receiving messages, whether I target one using the send methods, or whether I broadcast to all my clients. The code looks easy. We've seen it was just the received methods in which we receive a JavaScript object that we can use and further process whenever data is received. And I didn't do polling. I didn't have to worry about WebSockets or whatever technology that was being used. I just wrote code. I had a connection model that I could use and send messages across the wire, but I didn't have to care about the underlying implementation. Just like with jQuery, you don't really have to care about how you attach a click event to a button, for example. So connections and hubs. We've seen the persistent connection, and that's actually one of the two connection models you have in SignalR. SignalR has a persistent connection, which is just a class that allows you to have users calling into an object on the server, and that you can use to return data to the client. It's some sort of an HTTP handler, and it requires a route to be defined. So you have to explicitly map a URL to a specific connection in SignalR. It's limited to sending messages. On the server, I had send and broadcast. On the client, I just had the receive message. And actually, I could also use the send message from the client to send data back to the server. But just two methods. It's the same. It's a little bit the same like with WebSockets. I just have a raw, some sort of connection between the client and the server, but I actually have to implement all the logic of separating different kind of messages and payloads that I send between my client and my server. So the persistent connection is actually the protocol or the raw connection being used in SignalR. Next to that, you have hubs that you can use to, well, simplify your life a lot. It's just an extension on top of the persistent connection, and it allows you to connect with one or multiple clients. But it's an abstraction. It automatically maps a route. It gives you a rich object model. You will get it in IntelliSense, actually, in Visual Studio when you use a hub. And you can just call methods from the client. You can call a method on the server. But from the server, you can also call a method on the client, which makes it kind of transparent that you have a connection. You just call methods on either side of the wire. SignalR defines the protocol. They make sure that if you call some methods that is somewhere on the server, SignalR will make sure that method is called, and vice versa. It will also make sure the same method is called on the client afterwards. But you don't have to care about the protocol. SignalR will do it for you. You just write functions on the JavaScript side and methods on the C# side. So let's give you a quick demo about that as well. I have my web application here, which was the one I created, and I'm going to add some more code in my global.asx. What I'm going to do is, next to my tweets connection, I'm going to add this person class. Why a person? Because I'm inspirationless. It's a string, and the person has a name. Actually, the person will have no use in my demos, but I just want to use it to quickly demonstrate that actually if you build up an object on a JavaScript side, you can send this object across the wire as well and get a full CLR-backed object back into your C# code. So I'm going to do this, and I'm going to create a hub as well. This will be my worker hub. It will inherit hub. Not hub module, but hub, which is, again, a base class that's in SignalR. I'm going to name my hub. So I'm going to give my hub a name using the hub name attributes, and I'm going to call this worker. Just to, again, have some sort of mapping between an endpoint and what you want to use in your codes. So I'm going to use the worker class. And what this one will do is I'll just make sure that I have a method that starts some work that I can trigger from the client. And I will just have a nice progress bar distributed across a number of clients. So, a public void. This doesn't have to be a void. If you want to return a string, your JavaScript will actually get a string back if it calls into these methods. So I have a public void do work, for example. And I'm going to pass in a person called P. And in there, what I'm going to do is to my caller. So the one actually calling this method, I'm going to notify him. Work has started, comma, plus p.name. And at the end, I will, again, caller.notify work has ended. In between these things, what I want to do is broadcast actually a progress bar to all my clients. I want to target one client at the beginning and at the end of the method, just to say work has started, work has finished, but also broadcast the actual progress to all our clients. Now notice the notify property actually doesn't exist on this caller. So caller is a dynamic object, and I'm just calling a notify method, which SignalR will map to JavaScript code. So if I have a notify method in my JavaScript code, this code will actually call into that method on the JavaScript side. So in here, let's caller.set progress 0. Just make sure every progress bar starts at 0. And then for int i0, I smaller or equal 100, I plus plus. I'm going to my clients, which is also this one. I'm going to broadcast set progress to I. So what will happen is that this loop will just run. It will notify my caller that the work has started, and it will notify all other clients of the progress where we are. Just to make sure you see something, because this one will execute very fast, we're going to make this a Windows progress bar. And we'll make sure that if I is less than 50%, we will only do a thread.sleep of, let's say, 50 milliseconds. Then when I is smaller than, well, let's say 60, we'll make it a little bit longer, 250. If I is smaller than 96, which is typically the moment if you're at a friend's place and you have to do a virus check and a malware scan at your friends. This is the moment where you think, okay, I really want to go, and that's the moment. I'm just going to demonstrate it, what I want to say. That's this moment. So you see what's happening. I'm going to create a real Windows progress bar. Okay, let's add some HTML as well. So I created a hub class which will just handle a method call which will call back into my client, and that's everything. I'm going to add a new item, again an HTML page, which will be my progress bar. Again, I'm going to install another NuGet package, which is jQuery.ui.combined. Yep. Just to make sure I have all the jQuery, CSS, and images and everything, so you actually see a progress bar and not just a white square going into a white square, basically. So what I'm going to do is add some scripts in here. Of course, jQuery. I'll take the minified version. I'm going to add jQuery UI as well. I'm going to add SignalR, and I want to make sure I have the style sheets from jQuery UI. There we go. Now there's one extra script I have to add here, which doesn't exist in your project, and which is some kind of a virtual URL, which is the SignalR SignalR/hubs. Let's do that again. It's a virtual endpoint, an automatically registered route, which will actually create some sort of a JavaScript proxy to the hub we just created in our code. So this one will actually introduce an object called worker on which I can call the doWork method. So let's use that. I'm going to add some HTML in here, a nice div, which will act as my progress bar. A nice div which will just display the notification work has started, work has finished, and a trigger to just start work. So let's add some scripts. Again, jQuery, whenever my page is loaded, I want to, first of all, make sure my progress bar is a progress bar. So let's search for my div, call the progress bar method on it, which is coming from jQuery UI. And I want to set the value to 0. It will automatically do this, but this one makes it easier for me to just copy paste and adapt my code, being honest with you. So the next thing I want to do is get a reference to this hub I created on the server side. I want to make sure I can call into this doWork method. So what I'm going to do is just going to create a variable named worker or whatever. And I'm going to get my connection dot worker. This one corresponds to the attribute we added to the worker, and we're just going to get a reference to that object, and we're going to use that in all of our codes. Next thing we want to do is on our connection, make sure that the hub connection is started. We've seen the persistent connection, and we had to do something called $.connection.start. Well, here the hub is actually a new type of connection, and we want to start that separately. And you can use both in the same page, but we just want to make sure every hub can be connected to. Also, if you have multiple hubs, in this case, I have only the worker, but if you have multiple hubs that you want to connect to, this one will actually start the connection to all hubs that you have been referencing here. Okay, my worker. Whenever I have my, start work trigger called, whenever someone clicks that, I want to execute a function which will call into my worker dot, what did I call it again? Was it doWork? Yep. So doWork. Notice that I can just call into it like this. It was upper camel cased in C# code, but in JavaScript it's typically Pascal cased, and I'm going to use this one. And I'm also going to pass in an anonymous object. So I had my person object, and I just want to demonstrate that I can actually create a JavaScript object, send it to the server, and use it there. So do work. Okay. If I run this, you will still not see anything, but I just want to make sure that I actually get into this connection. So let's go to my progress. There we go, start work, and you will see I'm just calling into my hub, the same method. I actually wrote JavaScript code, called into the do work method, and I'm getting there on my server side. No services, no APIs, just plain JavaScript and C#. Okay. Now I had some methods. I was using the caller.notify, so I will require a JavaScript method called notify on my client side because my server is calling into that method. So caller.notify. So what I'm going to do here is go to my worker, create a notify function, and my notify will receive a message. And what this one will do is just find my notifications div, that one, and set the HTML to the message I received. So whenever I start work, I will receive a message that I started doing all that work. Now I also have another one, which is the worker.set progress, where I receive a new value, progress, and where I just want to update my progress bar. So in there, again, I'm just going to write some code which connects to my progress bar and just sets the value to this one. I'm calling a method that sits on the server from my client, but I'm also allowing the server to call into methods that are sitting on the clients. So let's run this one again. And I'll actually run it in multiple browsers. Let's add Chrome into play as well. So Chrome, and I'm going to start work. I'm just going to disable that breakpoint. And you will see that work works. I actually have a Windows progress bar. My original caller received the message work as started, but yeah, this is really the annoying moment in a progress bar. Work has started for my caller, and I'm broadcasting the progress to all my clients, but I'm just sending one message to one client as well. Work has started. Oh, still no. I want to go home. I'm not going to wait for it. And then you tell your friends the PC will be okay if you just reboot after the progress. And the next time you're there, bring your Windows CDs. True story. Way too often, actually. Okay, hubs. So we've seen the hub allows you to call into server-side methods from the client side, and also allows you to call into client-side methods from the server side. And the hub allows you to target one client, so the caller.some methods construct that we used. You can target all clients. You can just say clients.blah and then call into the blah methods that's sitting on all the clients. Or you can target a group of clients. Actually, when a client connects to your server, you can assign him to a group. And for example, Jabber is one crazy thing built by David Fowler again. He has way too many time. This morning in the keynote with Scott Goo, someone asked if he sleeps. I think this one even sleeps less. It's just a chat room built on SignalR. I have different rooms. So actually what he's doing is grouping these clients into groups named by the chat room name, and then sending messages across all. So I can be in the lobby, I can go to one room, another room, I can talk to other people as well, I can send messages, I have a help with a lot of stuff. I'll just send an away from keyboard because I shouldn't be chatting while presenting. Someone's sending me a message. So you see, it's just the old style IRC in our browser. We have direct notifications. If someone sends me a message, the server will push it to my client. It will not actually push it, I don't know, because the transport is unknown to me, but we'll make sure the message arrives. So that's fun to work with. Okay, clients. So far, we've been using JavaScript, and we've been using ASP.NET and some C# and stuff like that. But actually, there's more. There's a lot more. You can host SignalR in any ASP.NET application. So ASP.NET MVC, web forms, dynamic data, whatever you're using, you can host SignalR in there. You can host it on Windows Azure, and you can actually scale it out across multiple servers. So if you want to have this chat room and you're really, really popular and you require more servers, the Windows Azure code will just make sure the data gets distributed across all these servers. And one interesting, who of you has been using Node? Okay, one guy. Actually, there's a self-host as well. So if you want to write a service, a class or a hub or a connection on a server, and you want to expose just that to your client, you can actually host it in a standalone executable and make sure you have a small server that is hosting your SignalR services. Now, on the client side, it's also very interesting. You have JavaScript. You have any .NET client, so you can have a console application tapping into this progress bar as well. You can have a Windows Phone application tapping into my progress bar as well. You can have your iPhone, your iPad, tapping into that progress bar. There's an Android library, so basically on every device you want to use, you have this abstraction of the connection to use underneath there, and you can use it to build rich applications across multiple devices. Which raises a question. Is this a replacement for WCF? No. WCF has a lot more enterprise-ready features. It's more focused on offering services, while this is really just for having real-time connections. You can do stuff like this with WCF as well, but it will be difficult to have that on all these types of clients. So it's not a replacement, just look at it standalone. It does some similar things, but it's different. And I'm going to give you a next demo. I was talking about all these clients, and I've actually had a weekend where I had a lot of time. And I created a small website, which is this one. I'm going to start it. A small website which allows you to create slides using HTML. So typically slides have bullet points on them, so why not have a slide where you can have something like this. An H1 will be an entire title. If you add some bullets, for example, you just want to have some bullets on there. If you want to have a quote. This is just some CSS and some JavaScript to make sure you can go back and forth between different slides. So I'm the presenter now, and I can just navigate through my slide deck very fast. Okay, you see the URL is a present URL, and I'm connecting to a slide deck named sample. So what I'm going to do now is open up another browser, let's say Chrome, and I'm not going to present, I'm going to view sample. And you will see Chrome has some more CSS3 transitions built into it, so it will be a little bit nicer in Chrome, but you will see you have nice transitions. And whenever I go back and forth, all my clients will go back and forth in the slide deck. Let's add another one. I also have a console client, because people like to watch presentations in DOS mode. I'm going to connect to the sample deck as well. And you see I'm on that slide. I'm going to move, and my console moves as well. I get the data, I get the transitions, all that fancy stuff. Okay, in IE, I'm also going to switch to viewer mode. I will tell you the truth about this. I also created a WPhone 7 application to this as well, but my Silverlight skills are not that good. So I just created one part, which is the presenter side, because that was way easier. I'm going to connect to the sample slide deck. I'm going to show you all my clients. Console, where is it? And I'm just going to go to the next slide, and the next slide, and the previous slide. And see, multiple devices, one programming model, and it's really easy to use SignalR in those situations. Okay, let's quickly, because I'm almost out of time, touch the code of this. We've seen the JavaScript side. So you have a presentation hub in which I'm just assigning my clients into a group. So whatever happens is whenever someone connects to a presentation, I will quickly add him to a group called deck ID. So if I connect to a deck called sample, I will add this client to a group named sample. Afterwards, if I want to broadcast a message, I can just say, well, every client on this deck ID list should receive this message or should be called this method on. On the .NET side, things are actually also pretty easy. I'm going to show you this one. Also not using any MVVM or something. In here, I can also open a connection to my hub. I create a proxy to it, and using reactive extensions, I can subscribe to an on event, and on show slide, which is just if the server calls the show slide methods, I will be called into this callback function, and I will just update my UI or execute something in my code. So it's using reactive extensions just to react to everything that happens on the server side. You can do something with that and have your UI updated or whatever you want to do. Okay, so this brings us to the summary. SignalR is 3-in-1. It's like toothpaste, really. It abstracts the transport. It gives you some sort of persistent connection. You don't know if it's actually a persistent connection or not. It will just use one of the mechanisms provided by both the client and both the server. And it gives you a protocol. You have a means of calling into methods on one side of the connection or on the other side of the connection. You don't have to care about dispatching data or method calls to some other method. No, SignalR does this in your place. You have connections, which is the raw socket in SignalR. It just has a send and a receive method on both sides of the connection, and you can build your own protocol on that one. If you want to use the SignalR protocol, just create a hub, and you can just call methods on both sides. Actually, I didn't show you, but if you have a property on your hub, for example, and you access that property on the client, you will get the fresh data. It will actually abstract that property call as well. You can connect various clients. So if today you want to go and make the web real-time, you can do so with SignalR and Android and iPhone and iOS and whatever you want to use for that. I was also asked to have a call to action, and I thought this one would look nice on a cinema screen. Make the web real time. Install SignalR, go play with it, and have fun with it. It's really fun to work with. Find some other stuff, HTML5 stuff as well on these sites. And with that, I can give you 1 minute of Q&A. So if you have a question, now is the time. Yeah. The worker actually didn't end, I think, in my demo, because the last percentile was taking 5 seconds. I think I had to wait 20 seconds for the demo to actually end. Okay, yeah. Okay, thank you. Yeah, exactly. The worker ended was just sent to the caller, so it wasn't broadcasted to all the clients. Anyone else? With that, I have some real-time information for you. The day is finished. Thank you.